this is sort of the general plan for what I'm trying to do today. So first of all, I want to give a bit of general context about DeepSeek and AI in China more generally. Then a bit of more technical discussion of DeepSeek's large language models. So that's depending on your background, either the part you're looking forward to most or where you'll fall off the deep end. And then coming back from that, wanting to talk some about implications for industry investments, geopolitics. And then after that, I will take an attempt to answer whatever questions people have. Okay. So starting off with the recent history, which you might otherwise call, how did these unknowns achieve this? And, it is quite a remarkable story. So DeepSeek is this sort of weirdo company, which as an AI company or technology company is small, even in China. CEO is Liang Wenfeng. And basically, it's a finance company that builds language models on the side. I mean, I guess weird combinations like this aren't completely unknown in the US either. So D. Shaw is famous for doing a lot of bio research, just as a side gig on the side of doing trading. So this is something like this. So, they regard it as this is a way that they can employ lots of intellectual horsepower of, IMO winners, IOI winners, all these sort of super talented people, and keep their lives fun by having them work on state-of-the-art deep learning models, as well as making money in trading. It's a possible company strategy. Yeah, but the other thing I want to say is, well, clearly this week we've been having this moment where it's now all over the Wall Street Journal, everyone else, oh my God, there's this amazing DeepSeek company that have shattered everything and done so amazingly. I mean, really, they're not new. They've been active, and what they've been doing has been very public for quite a while. And anyone that's following along closely with what's happening with models and what's being released has known about DeepSeek for quite a while. So, just like a few years ago, OpenAI was sort of bubbling along below the surface, and people are interested in NLP and large language models. Were really excited when GPT-2 came out, and then really, really excited when GPT-3 came out, but it didn't become pieces on nighttime TV until ChatGPT was released. It's really exactly the same story with DeepSeek. Just to remind you of timelines, November 30th of 2022 was when ChatGPT was announced. And so that was really all over the world, people understood that the world was different. And it's not that there'd been no work in China on models before that. There had been back in the GPT-2-3 era, but I think that really got everyone's attention and set off an enormous amount of LLM R&D in China. And so it's then roughly 1 year after that you're then seeing a lot of good models coming out of China. So, I put the date up here. So 1 day short of a year later, DeepSeek released their first LLM. So this is slightly over a year ago, right? So they have been around and quite public for quite a while. And so this was, and in retrospect, I guess we'd call this V1, but at the time they just called it DeepSeek LLM. And, it was already, really this was, I think, they're learning how to do this stuff, but, it was already a very good model. So essentially for this one, they sort of mainly copied the Llama 2 architecture. They made some changes as already thinking about hardware efficiency as to how to get things to run fast, which is sort of really the trademark area in which they've been doing a fantastic job, so that they were starting to use group query attention and favoring depth rather than breadth. But, in this chart here, this is showing scores on this axis of the GSM 8K, so grade school math problems, and these are sort of Hungarian exam problems. But, it was already the case that, here was GPT 3.5 Turbo, Here was Llama 34B. Here was Claude 2 and GPT-4. And here was DeepSeek LLM, so that they were, a bit behind GPT-4, but not so bad for their first effort. I guess they've been bringing stuff out every 6 months, so then in 6 months ago, they produced DeepSeek version 2, which, actually already started to pioneer some of the distinctive things that you've seen in their most recent models. So this is actually where some of their architectural innovations came. So I'll talk about it a bit later, but, one of the things that's distinctively theirs, which other people haven't been really using so far, is this multi-head latent attention, and that was already in DeepSeek version 2. And so this was a much bigger model, and it was a mixture of experts model. I'll get back to that. So this was 236 billion parameters, and so they sort of showing that they were getting, good performance in an economical way, because the mixture of experts model allows you to sort of have much less active parameters and then much less computation. And so effectively, they were sort of performing as well as then Llama 3 or Mixtral, if you want to compare to that, in a much more economical way. And then we're going to get to in a minute DeepSeek version 3, but that's going to be the more technical part of the talk. But I did want to sort of say, at the moment, the news in the US has all gone DeepSeek, 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 as if that's the only player in China. It's not the only player in China, right? There are companies falling over themselves with large language model companies in China. So we know about DeepSeek. So, traditionally the 3 big tech players in China were Baidu, Alibaba, and Tencent, and all of them have large language models. The one that is best known in the West, and I think is the sort of best performing one, is these ones, Tianwen, which normally gets mauled and pronounced Quen in this country. But, they've got very good models. ByteDance, TikTok, and Huawei, they've got models. But, then there were also smaller models, smaller companies. This is Kai-Fu Lee's company, which has had quite good models. There's a ... here, but there's more of them, right? So it's very small, unfortunately, so maybe I'll have to read it out. But, this is pasted from this morning, the Chatbot Arena leaderboard. There are many different evaluations you can look at, but one that quite a lot of us like quite a lot is Chatbot Arena, because in some sense it's just close to real-world humans talking to language models, since it's exactly humans talking to language models and saying which of these 2 models do you like the response of better, and giving a judgment. So, how do things look on this leaderboard? So Gemini's winning at the moment. I think many people haven't quite caught up with the fact that Google, despite the fact that it seemed to be a slumbering giant for quite a while. So the top 2 things on the leaderboard are Google's Gemini models. Then there's the latest GPT-4o, and then here's DeepSeek R1, which we'll come to. So one of the questions somebody asked in advance was, is R1 only good for reasoning, math, and code? And the answer to that is no, because look, here it is, DeepSeek R1 right up here. In particular, that means it's sort of closer to ChatGPT 4o in terms of general chat performance than OpenAI's own O1 models, which are a bit further down this leaderboard here. So they're doing well on that. So after DeepSeek, there's another Gemini model. Then these is O1 and O1 Preview. This is then, we'll get to in the next section, DeepSeek V3, which is actually the base model out of which R1 was built. And then, unless you're following very closely, the place where you'd really sort of stop and go, WTF, who is this? Is the next model here is Step. And Step is actually another Chinese company. So Step AI is a new out of Shanghai Chinese company. And lo and behold, here they are at whatever they are, about 9 on the leaderboard, even though I think almost nobody in the US has heard of this company. So if it's not becoming obvious already, I think one of the messages that you want to take away here is there is no moat. You need a certain amount of resources, you need some data and some compute and some smart people, but any idea that there are companies that are years ahead of other people and other people can't start fresh and catch up, just not true. I mean, I think there's some lead you can have, but it's starting to look more like the lead you have is 6 months rather than any amount that's really bigger than that. I should probably about stop here, but you know, O1 Mini, Gemini, Grok, the XAI model, E-Lightning, so that's then the Kai-Fu Lee 01 AI model, GPT-4o, and Claude. Yeah, so here's Anthropic's best model on this chart now, Claude, right down here. And then here we have the Tianwen model. Yeah, so, you know, I imagine at Alibaba Cloud, there are some people thumping the table at the moment and saying, why isn't this us, not DeepSeek? But, you know, it's not that Alibaba doesn't have great models. I mean, Alibaba's models have been widely used as also open source models that are good models. Yeah, so that's the general background. So more technical discussion of DeepSeek R1. So really, you know, a lot of the technical stuff is really about DeepSeek v3. DeepSeek v3 was released on Christmas. That's a good way to make sure it didn't get a lot of attention in the West at the time. But, you know, that a lot of what's gone on has really been in DeepSeek v3, and DeepSeek R1 builds on top of it. DeepSeek has been, so mixture of expert models aren't unique to DeepSeek, so Google's using them for Gemini, OpenAI is by everybody believed to be using it in their GPT-4 models. But you know, DeepSeek has been very successful at producing MOE models with very large numbers of experts. Highly MOE models, DeepSeek MOE they call it, they have running very reliably, which is sort of something that's a little bit hard to do. They've got a distinctive form of attention that they've worked on that's very sort of data flow efficient, multi-head latent attention. And so using these two things, they're able to greatly using these two things, and also by doing training almost exclusively with 8-bit floating point, they're able to greatly reduce the computational costs of their models. So in particular, this model was trained on 2,000 H800 GPUs for 2 months, which is, you know, the cost of this compute is about $6 million worth of compute. Now, of course, you know, that's not every, you know, one run does not give you a large language model. There's lots of other runs that were done, and they have lots of other computers so that people can be doing things on. We can get back to that in a minute. Okay, so in the sort of the architecture they have for this model, you know, transformer architectures like everybody else, and the two distinctive parts are that they've got their own way of doing attention, and then it's instead of fully connected layers in the transformer, they're using these many. And so the end result was that DeepSeek version 3, as we already saw on that other leaderboard, was a very strong model in all about R1. And so this shows results where the columns on the left are DeepSeek version 3, and it's comparing it to their previous model, the Tianwen model, Llama 3.1, GPT-4o, the sort of early release, I guess, and Claude 1.5 Sonnet. And in particular, it seems to be working very well in coding and math kind of things compared to some of the other models. Even more benchmarks, which maybe I'll skip lightly past. It's a good model. Okay, and so then more recently, just in time for Chinese New Year, in fact today is Chinese New Year, Happy New Year to those who celebrate, that they released DeepSeek R1. So they released a bunch of models, so if you haven't already woken up to it, all of their stuff is very open. If I just detour slightly from the technical narrative for this, I mean, we're in this bizarre world at the moment where the best way to learn all the details about large language model training is to be reading papers by Chinese companies. I do not think that's a very good state of the world, and I think it's about time the US did something about that. But anyway, so they've sort of released everything. So DeepSeek R1's the premier model. R10 I'll explain in a minute. But then they've distilled from their best model sort of a series of dense models, which are sort of all the common sizes that people use for llama and other things. Okay, so what's different here? So first of all, quickly, this is just training a modern LLM in general. So LLM training at large scales has become, this big data engineering pipeline, and that's essential for success. So you start off with your neural net with random params, and you take gobs of data, trillions of words of data. For them, I think it's around 16 trillion words of data that's used for DeepSeek version 3. And so you train a model, and then you've got a pre-trained model. And then you'd like your base model to have lots of other desirable characteristics and have seen particular kinds of data and know about it well. So then you do some more training on some carefully chosen data, and then you get a mid-trained model, and then you want and so that's sort of a base model, and then normally you're actually wanting to produce things like instruct models or chat models that will answer people's questions, and then you've got an SFT trained model, and then the final phase is reinforcement learning, or at any rate some kind of preference optimization. We talked about DPO in another talk on preference data. And I forgot to change this, bug in the slides, RL, and then you get this post-trained model, and that's kind of the standard picture of O1 is then to be saying, look, rather than just concentrating on training this huge model, we can make models a lot better by having them think a lot, run the model for a long time, generate tons of tokens to work out how to solve problems. And so this was essentially pioneered by OpenAI's O1 model. It has its precedent in the kind of let's think step-by-step chain of thought that people were manually doing, but it's sort of automating that in the model. So, prior to the release of DeepSeek R1, actually towards the end of last year, DeepSeek released R1 Lite Preview, just the same as OpenAI had an O1 preview. So this was kind of coming. So this chart is actually from that release, and what it's showing is for its ability to solve math problems. These are AIME kind of IMO style math problems, that its performance just goes up enormously from about 20% with a little bit of thought to 3 times that, getting about 66% right with a ton of thought. So at this point, to answer one problem, you're writing out from your LLM about 100,000 tokens or more. So you're doing a lot of scratch work to get the answer out. Okay, so what are the novel parts of V3 and then R1? So one of the novel parts is in their attention computation. So there's classical transformer QKV attention, which is what I teach in class, but this is pretty expensive. So everyone doing modern language models has a bunch of steps beyond that. So everyone uses a KV cache, which is what's actually shown in the diagram to the right, where you can kind of store your key and value projections rather than recomputing them every time. That's an obvious start, but it's still kind of doing this, people started to explore ways to reduce the computation. So you can do multi-query attention, which means that rather than having separate keys and values for every attention head, you reuse the same ones and only change the query. And then you're not gaining more by having the same reused KV on different machines. So group query attention is then a middle ground where you have some different Ks and Vs for each machine. Both of these decrease performance, but this one not very much and that one quite a bit. Now, DeepSeek actually pioneered a different idea of their own, where what they're doing is they are doing a low-rank decomposition of the KQV matrices, which is sort of like standard linear algebra math. And so then what they're storing in their KV cache is the low-rank decomposition, and that's how they're storing the queues as well. And then they're sort of reinflating them at the time that they do the computation, so that they're sort of trading additional computation for much lower data flow, which gives them a big win. Yeah, so that's one of the ways that they're reducing the amount of computational demands that they have. And I mean, that change actually makes a huge reduction in the computational demands. I'm not going to go through all the other technical details. I mean, but one of the things that one can take away from the paper is that DeepSeek has done an enormous amount of very careful work looking at data flows, looking at amounts of computations, and working out how to reduce it in every way possible, including doing very low-level work, working with NVIDIA chips beneath the level of CUDA to make things more efficient. And, you know, if you wanted to be critical of American industry, you could sort of feel like American companies are, by comparison, a bit fat and lazy, or at any rate, they want to move fast. Okay, then the more interesting part is then how they do reinforcement learning. So in the picture that I showed before of the standard model, and they do this as well, but after you've done your sort of general training and even some further steering with supervised fine training, right at the end, you're doing reinforcement learning to better steer the model so it responds to instructions like that. And that's, you know, been very successful. The general picture seems to be that, you know, supervised fine-tuning is good for fixing point problems, whereas the way you're training it by reinforcement learning or DPO or something like that generalizes much better. And they do that too at DeepSeek. But additionally, they do a rather interesting process where they also do reinforcement learning to create data. So they have this longer process where, first of all, they're training something that's just a good reasoning model. So this is one that's meant to be good at code, math, problem solving, reasoning of all kinds. So possible reasoning model that they can, and then they say, okay, let's use that reasoning model to create a lot of reasoning data. And what they're addressing here, and you know, I think you'll find that OpenAI did roughly the same for O1, apart from, you know, they don't write tech reports anymore, so we're sort of guessing from obscure tweets and comments, podcasts and things like that, is the problem trying to get reasoning out of these models is they don't really see much in the way of examples of reasoning. They mainly see sort of questions and answers. And so if you can have a model that can reason and you can generate very long reasoning traces, then that gives you a lot of very explicit data to train on, which can let you build a model that can reason much better. But, you know, their pure reasoning model, or R10, is a pretty good model, but they also want a sort of a general conversational model in their R1, which they did pretty successfully. The general training of DeepSeek R1 model, including sort of doing the normal kind of reinforcement learning at the end. Code and math and things like this. So this is now showing DeepSeek R1 versus, at this end, their DeepSeek version 3. So these are the kind of, you know, IMO style problems, math problems, AIME 2024. So they're massively better at doing math. This is code forces, difficult code challenges. They're massively better at doing those. But for something like the more text-based language understanding things, the progress over version 3 is minimal and the performance is similar to what other things are producing. Okay, implications for industry investments and geopolitics, and maybe we can have more of some of this in the questions. Have OpenAI, Meta, Microsoft, X over-invested? Maybe a bit. I suspect, not dreadfully. I mean, the fact of the matter is, compute is super useful and it makes sense to have a lot of it. I mean, I think, there's clearly been revealed a certain laziness and you can get a lot more done with the compute you have, though to some extent you're trading a lot of human hours of work for buying hardware, and humans cost a lot in this country as well. But, to explore models and build different models, you need a lot of hardware. I don't think companies are really going to regret the fact that they have a lot of hardware for model development. But secondly, but extremely importantly, for anybody who's actually delivering a product, whether it's sort of OpenAI selling their models or someone like Meta who's using their models everywhere internally, the majority of your compute is actually going to inference, not training. And that inference is still all needing to be done. Now, again, the DeepSeek models are more inference efficient, the way they've done it with FP8 and sparser MOEs. So, they've been pushing down inference costs as well, and that's where you get this headline result that R1 inference only seems to cost about 10% of what you're paying in your OpenAI bills. So there is some good technology there, but luckily it's all open source, so the rest of us will be able to copy it, I guess. But I think computing will get used. And so, I don't think this is really bad for NVIDIA, right? So what everyone's talking about now is, as Sean mentioned, Jevons paradox. And, basically that's sort of really just about demand price elasticity. And, I think it's just very clear that demand for compute is extremely elastic as the price comes down. And I mean, you don't have to look at supercomputers for that. You can just, touch your iPad screen, right? The amount of computation that's being used to do those swirling graphics when you press on your iPad screen is an amount of computation that people in the 20th century would have only dreamed of having. But these days it's so cheap, we just like looking at the nice graphics. So I think there'll just be, this is expanding the market, it's improving the level of open source models available, and so that's going to lead to more and more people wanting to do things, and NVIDIA will be selling their product just fine. This was a little aside. I shouldn't talk for too long. So, there's issues here of geopolitics, right? The Biden administration tried to limit GPU purchases by China. There was a first round of limitations, and then there was a second round of limitations. The first round of limitations with respect to this was basically just ineffective, right? Because not quite. There were sort of two main limitations. One was on the speed of the interconnects, and so the chips that were then legally sold in China had to throttle the NVLink interconnect speed, and that actually does make it much more difficult to train big models, though DeepSeek has developed some very clever workarounds for that, so that they can still do things pretty well. The other part was throttling the amount of compute. But because they throttled the amount of compute in terms of counting in bytes that effectively throttled the amount of compute if you were doing FP64, FP32. But the clever folk at DeepSeek have worked out how to stably train their models almost entirely using FP8, 8-bit floating point models. And the H800 is not throttled at all compared to an H100 in terms of FP8 compute. So sitting pretty there. But, there's some interesting geopolitics here because, Huawei is making their Ascend chips, the 910B and now the 910C. And, they're not actually such bad chips relative to the NVIDIA chips. I think the problem is that they can't make enough of them because they're short of lithography machines. But, interestingly, DeepSeek version 3 runs natively on Ascend 910C chips for inference, not yet for training, because the interconnect speed of the Huawei chips is way worse than even the throttled NVIDIA chips. But, so that's going to start to be a new world. And even though there are some constraints in place, clearly the Biden restrictions are just actually causing this huge flowering of the domestic Chinese chip industry. So I don't think that's going to hold things back for very long. Okay. There's then also a lot of speculation on how many chips does DeepSeek have. I mean, they have at least 2,048 H800s. They say that in the paper as what they use for their final training run, and I presume they're being honest about that, because since they give all the specs on how much data and how many hours of training and how many GPUs connected how, I mean, they'd have egg in their face in a matter of weeks as other people try to replicate if they haven't told the honest number. Now, obviously they have more than that. I think there is a fact that the narratives from China are trying to minimize the amount of compute they have. We're so clever doing it with so little, and some of the narratives from the US lately are saying, oh no, there's been, enormous illicit shipments. They have over 50,000. I suspect the truth, is somewhere in between. Maybe they have 10,000, maybe they have 20,000. I don't know. You choose your own numbers. But, they're certainly showing that you can build models successfully with less GPUs than Elon Musk is building in his XAI data center. Is the model safe? It's certainly safe to be put into the Chinese market, though there are slightly different safety criteria there. Sean already said a moment about AIX strategy. I mean, AIX hasn't been investing in the base model building companies, and I think there's more and more evidence that this is going to be a commodity. That doesn't mean that some people can't make money from this commodity in the same way as AWS is making money from selling compute, but it doesn't seem like it's going to be a very high margin business. So we've really favored people who build products, apps that connect to people rather than baseline training. What does this mean globally for AI development? I think this is my last slide. So, just to give 3 quick thoughts on that, this doesn't mean that any of the US companies are out of the race, right? It's not that this is light years ahead of what OpenAI has or what Anthropic has, right? It's basically similar level of technology to what's in O1, so probably it's not quite as good as what's going to be in O3, right? So, it's very much everybody is doing it, and so in terms of anything like AGI timelines, I think it neither makes it sooner or further away as to when that's going to happen. So it sort of seems like, to the extent there are implications, it's not that. The implications are, firstly, on the side of open source, that to the extent there was the thought that you had this sort of closed frontier compute and open source was a long way behind, this seems to make very clear that open source is only 6 months behind. And, well, it's impossible to predict the future, but at least so far in interviews in Chinese media, Liang Wenfeng has wanted to say strongly that they are in open source for the long haul. They're not going to do an open AI and shut it down once it gets good. They're going to keep open sourcing it, and that's the way it's going to be. So if you believe him, it's going to stay that way. And then for geopolitics, I mean, it's sort of then clear that there's this reality that people are going to have to become more accepting of the fact that it's not the case that all of the best models are sitting in the great state of California. Okay, I am done.